right, let's get started. So if you haven't seen the announcement yet, assignment 1 was posted on Sunday. Can you actually see it here? Oh, wait, I have to do, how do I do this? Assignment 1. And so if you click on that page, if you click on that link there, it'll take you to a page of instructions. There are a lot of instructions, so please read them carefully. In particular, read that line carefully. Inevitably, if someone doesn't download the Eclipse archive file here that you're asked to. So instead, they click on it in their web browser, and then their web browser automatically opens it up and extracts the file for you. If you do that, that complicates importing the project into Eclipse, so don't do that. Right? Follow the instructions there. There are a lot of instructions, but they're there for a reason. So just take your time and read them. The assignment is literally translate a Python program into Java line by line. Right? So when you see a function in Python, you just translate it to a method in Java. Where you see an if statement in Python, you just translate it to an if statement in Java. Where you see a loop in Python, you just translate it to the corresponding loop in Java, and away you go. Right? So it's straight translation. It's almost one for one, so it's almost line per line. And it's not too hard. So you have a week to do it, and then all the other assignments you'll have 2 weeks to do. Okay? The first one's not very long, and it literally is just translation. If you get it working, you get to see I guess it's a semi-interesting example of a simple image processing algorithm. Alrighty, so at the end of the last lecture, we were talking about if statements and logical operators. So and in Java is the double ampersand, right? So if you want to check if you want to return the largest of 3 values, A, B, and C, right, you can just compare A to B and C, right? If A is the largest value, then the answer is A, right? Otherwise, you just compare B to A and C. If B is the larger value, then the answer must be B. Right? Otherwise, the answer is C, and away you go. Right? Or is a double vertical bar. Right? So here's the code for a leap year method. Right? Returns true. If the year is a leap year, returns false otherwise. Right? So here we've got the OR operator here. And, right there, right? And has higher precedence than OR. So the way that this expression is evaluated is this part over here is evaluated first. Right? So if that part is true, then this part over here is evaluated. Right? If this part is false, then the answer must be false. So it turns out, yes, that's correct. So if that and that, right, so then that won't be evaluated there. Right? Now in this example here, you're just returning the result. Right? If this logical expression is true, you're going to return true. Right? Otherwise, you're going to return false. There's no reason to use an if statement in this case. All you have to do is return the result of the logical expression, right? So instead of, you can use parentheses if you want to make things easier to read or to be explicit about precedence, right? And finally, because you're returning the result of a logical expression, you should just return the logical expression and not use an if statement, right? Although if you're more comfortable writing this, then by all means write this, right? Eventually, you have to get used to writing this, though, or you should get used to writing this. All right, and the last logical operator that you need to know about is not. Right? So in Python, the logical operator not is NOT. In Java, it's the exclamation mark. Right? So assuming you have the is leap year method, I want to return the number. I want to write a method that returns the number of days in February for some given year. Right? The first thing I'm going to do is I'm going to check is that year not a leap year. Right? So if it's not a leap year, return 28. Otherwise, return 29. Right? So if you need not, it's the exclamation mark, right? Instead of NOT. And that's it for logical operators. All right. Moving right along. I think this is the fourth set of lecture slides if you're looking at the slides online. Okay, so you know in Python that a list is, you know how to create a list. You use the square brackets, right? And then you put in a comma-separated sequence of values to initialize the list, or to assign a list, or to create a list literal, right? You know that you use square brackets and an index right? An integer index to get a value from the list, right? So lists are indexed starting at 0, so T0 is the first element of the list, right? In this case, it's the string A, right? You know the last element in the list in Python you can get by asking for the length of the list. So to get the length of the list, that's len, right? And then subtract 1, right? That's the index of the last element. In Python, you can also use -1 on its own, right? Because Python allows negative indexing. If you're used to doing that, stop doing it because you can't do it in Java, right? Java doesn't have negative indexing. So you have to use this more awkward form here, right? Where you find the length of the list and then subtract 1, right? And finally, you know that assignment, well, you can assign elements to the list, again, using indexing, right? So if you write T square bracket 1, that lets me replace the second element in the list with a capital B, right? T square brackets 2 lets you replace this third element of the list with a capital C. So Python, that's true for lists, but it's true for a lot of other sequences as well, right? So for strings, you can use the same syntax, right? Square brackets. That's not true in Java. Python also gives you slicing. Do I do slicing? I'll do slicing in a second. Okay, now in Java, if you need something that looks like a list in Python, normally you would pick a Java list. But there's a second alternative, and that's called an array. Okay, so Python list is actually if you took a Java array and a Java list and mashed them together into one thing. So the Python list is actually, its syntax and its capabilities are like a combination of a Java list and array. So an array is more primitive than a Python list. It's more primitive than a, sorry, I shouldn't say primitive. A Java array is less capable than a Java list. It's less capable than a Python list. Okay? So an array in Java is a container object, right? So it holds elements, but it holds a fixed number of elements. Okay? Furthermore, it holds a fixed number of elements of a single type. Right? So in Python, where you can put anything into a list, in Java, you can only put elements of the same type into an array. Right? Furthermore, the length or the capacity of the array is fixed. Right? And so the length of the array is established when you make the array the first time. Right? So to declare an array, you use the element type followed by an empty pair of square brackets. Right? So double, square bracket, that says that you have an array of double values. Right? So this array can hold any double values that you, it can hold double values that you put into it. Its name is collection, right? Now in Java, this doesn't actually make an array, okay? So that's, all this does is make a variable. There's no array, right? So you've got a variable called collection, and it can refer to an array, but there's no array yet. So if you try to use collection and try to put something into it or take something out of it, you're going to get a, you'll get an error when you try to do so. Okay, so Java arrays are much less flexible than Python lists, but they also use the square brackets for indexing. Okay, so the syntax when you use an array in Java looks a lot like the syntax of using a list in Python. You don't get any slicing, which is inconvenient, right? Because slicing is actually very convenient in Python. You don't get negative indexing in Java. That causes a runtime error. You do get index checking. So if you try to use an index that's not valid for the array, you will get an error at runtime. And unlike Python, you have to specify the element type that goes into the array. Right? So first example here, right? Car square bracket t, right? That says that t is an array of car, right? Car is just the individual characters of a string in Java. I can use the squiggly brackets, the braces, when you initialize a list. Right? So I can use these braces when I declare the array t. Right? I can only do it when I declare it. I can't do it after the fact. Right? So later on, if I write t equals squiggly brace something, 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 you'll get an error. Right? So the braces are only allowed for initialization. Right? The first time you declare the variable and assign it a value when you declare it. Right? To get the first character out of the array, right, I need a variable called first, so its type is car. Right? And it's the same syntax as in Python. Right? Last is the same thing. Right? No negative indexing, so I have to write, I need the length of the array -1 To get the length of an array in Java, it's the array name dot and then the word length. Right? So it's not len's round brackets array name. Right? It's array name dot length. Right? You cannot change the value of length. Right? So if you try to write t length equals 5, you'll get an error. Right? So it's a read-only variable here. And then assignment to an element, it's the exact same as assigning to a list in Python. Actually, that's the example I meant to show you right here. So an array can initialize its size and elements. Oh, yeah, right, I didn't tell you about that. You can initialize its size and elements by writing the elements in a comma-separated list inside of braces. So here, t is an array of 1, 2, 3, 4 car. Right? So the length of that array t is 4. Right? If you try to write the following, so car square bracket u, right, that makes a variable called u that can refer to an array. Right? But if you, on the next line you write u equals braces something, that gives you an error. Right? So the compiler will complain and say that you can't use an initialization list for assignment. Right? So that's the other strange thing in a lot of programming languages that probably hasn't been made clear to you. Right? Well, I guess in Python it doesn't really happen. So in Java, when you declare a variable and give it a value at the same time, that's called initialization. Right? If you have a variable and then try to assign it a value, that's called assignment. They're actually two different things, even though they look exactly the same, right? Almost exactly the same. Right? So initialization, yes, you can use the square braces. Yes, you can use the braces. Right? Assignment, no, you cannot use the braces. Right? Okay, so normally when you make an array, it's sort of uncommon that you know the elements that you want to put in the array to begin with. Right? So normally when you create an array, you use this operator called new in Java. And there is no corresponding operator in Python that does the same thing. Right? So the new operator lets you create an array, and you specify how big an array you want. Right? So that's the capacity or the length of the array. Right? Those two terms are synonymous in Java. So the capacity is the maximum number of elements that the array can hold, right? Or its length. When you use the new operator, the capacity or length appears inside square brackets after the element type. Right? So here I say that collection is an array of double. Right? I don't have an array yet. I have to make the array before I try to use it. Right? So I can write collection equals new. Right? What's the element type? Well, the element type is double. Right? How many elements can the array hold? Well, this one can hold 10 elements. Right? So you can write that as well. You can also write equals new double 10 up here. Right? So you can also use it for initialization. Okay, if you have a primitive, if you have an array that holds primitive elements, then when you write new blah, Java automatically fills in the elements of the array. Right? So here, I've got some bools. Right? It's an array of Boolean. Right? It's an array of 3 Booleans over here. Right? So Java will automatically fill in that array with 3 values that are equal to false. So the default value for Boolean in Java is false. Right? So you get an array of 3 falses. Right? For all of the other, for all of the numeric types, the default value is 0. Right? So when you write in square brackets some ints, right, equals new int 4, you get an array of 4 int zeros. Right? New double 5 gives you an array of 5 double zeros. Right? So when you print these out, you'll get false, 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 true, true, oh sorry, false, 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 0, 0, 0, 0, and then 0.0 5 times. Right? Now, when you go to print out an array, you can't just say print line and then the array name. If you do that, you'll get some gibberish. Right? You'll get a sequence of characters and numbers that won't make any sense to you. Right? So when you want, if you want to print an array, you have to call some method that converts the array elements into a string. Right? And so the method that does that is called arrays, big A, toString. That class arrays is that class right there. Right? So you haven't seen this syntax yet. You haven't seen Java dot something dot something. Right? So the class arrays is in the is what's called in the package java.util. Right? And so packages are a Java mechanism for organizing classes into for organizing classes. Right? So in this package called java.util, you'll find a whole bunch of classes that are useful. That's why it's in the package called util, right? Utility classes. Arrays is one of those classes. Right? We'll talk more about packages a little bit later on. Right? But arrays is a class that you need in this program, so I have to import it in order to use its facilities. All right, default values for arrays. So if you have a primitive type array, then Java automatically fills it in when you make it. Right? So for Boolean, you get false. For all the numeric types, you get 0. Right? And that's it. So that's pretty straight. That's pretty easy to remember. If you have an existing array and you want to fill it with values of the same, you want to fill it with you want to make all the values in the array equal to one another, you can use that arrays class and use the method called fill. Right? So here's my array of doubles. Right? I've got 10 doubles. If I print it out, I'll get 10 zeros. Right? If I fill that array with ones, right? So the method is arrays.fill, name of the array, value that you want to assign to all the elements. Right, and print it out, you'll get 10 ones. Right, so fill is a handy little method that will fill an array with the same value. You can write a loop too here if you wanted to, but using fill is a lot easier. All right, the number of elements in the array is stored in what's called a public field called length. Right, so when I make this array here, right, I know that it's an array of size 10. Right? To get that number later on, you just use the array name.length. Right? And that will give you the number of elements or the length of the array. Okay, so the values in the array, they're called elements, right? Which you should have been taught in Python. Right? The elements are indexed using a zero-based index, right? Just like Python. No negative indexing, right? Last index of the list of the array is always the length of the array minus 1. Just like in Python, you use the square brackets and an index to access an individual element. Right? So collection 0 equals or gets the value 100, puts the value 100 into the first element of the array. Right? If I want the first element of the array, it's just collection square bracket 0, right? And that's the first element of the array. So I can go up to 9, right? Because my array has length 10. Right? If I try to access or set the element at index 10, you get an error. Now, where is the screen? Sorry, the screen's not all the way down for some reason. Oh, it's fine. Right, so if you write collection 10 equals 100, then when you run this program, right, you'll get an exception. So that's the same thing as, you have exceptions in Python. So you'll get the exception, array index out of bounds exception when you try to do this. Right, so your program will stop running. It'll say the index 10 is not valid for this array. All right, what about loops, right? So why am I telling you about arrays? Because we need to write loops, right? It's not very interesting writing loops if you don't have a collection of some kind. So a common operation when working with Python lists is you loop over the elements of the list and do something, right? So if you wanted to manually find the maximum value in a list, right, you might write the following Python function, right? So this is for a non-empty list, right? If the list is empty, you get an error in Python. You'll get an error in Java, right? So assuming the list is not empty, right, we can start by assuming the largest element in the list is the first element, right? Now you just look at every element in the list, right? If you find any element that's bigger than the first element, well, your new largest value must be that element. Right? When you're done processing the list, you've got the largest element. Right? Piece of cake. What does it look like in Java? So Java also has a for each loop, right? So Python only has this kind of for loop, right? Python's for loop is a for each loop, right? For each element in a sequence. Right? Java also has a for each loop. The syntax is different. Right? Okay, so when I translate this Python function over to Java. Whoa, sorry. When I translate, okay, right? So the function name I change, right? So I don't use the underscore max underscore elem, right? I change it to max big uppercase E elem, right? You're using camel case in Java, right? I have a list T, so here I'm going to have an array ARR. Right? Now in Java, you have to say what the array type is. Right? So this max element method only works for an array of double. Right? It's not going to work for an array of int or an array of anything else for that matter. Right? It's only going to work for an array of double. Python, this works for any element where you can use greater than. Right? For any list in where greater than makes sense for the element type. Unfortunately, in Java, I have to specify the type of the array here. Right? I'm going to return a double value. That's the largest value in the list. Right? So first, I'm going to start by assuming the largest value is the first element in the array. Okay, now Java's for each loop is 4, and then round bracket. Right? Inside the round brackets, right? You create your loop variable. Right? So here your loop variable is elem. Right? In Java, my loop variable is also elem, but I have to give it a type. Right? So that's just the type of the element that's in the array. Right? So for each element in the array, colon means in the array. Right? So the way you read this is for each double element in ARR. Right? And now the rest of it is just a regular if statement. Right? Now the scope of elem is the body of the for loop. Right? So when you declare elem here, you can use it anywhere between these two braces. Right? And that becomes your loop variable. All right, so basically the exact same as Python, syntax is slightly different. Right? Now, in many situations, you want your loop variable to correspond to an index of an element. Right? So in other words, you want a counting style loop. Right? I want to count from 0, 1, 2, 3, 4, 5 up to the largest index in the list. Right? This isn't a particularly good example. This isn't a particularly good Python example because you don't have to do it this way in Python. Right? If you wanted to, you could write it this way. Right? Oh, sorry, I lie. You do need to do this because you want the maximum. This one returns the maximum index. This one has a mistake. I'm sorry. This is supposed to return that. Okay, so this one returns the index of the largest element in the list. It doesn't return the largest element. Right? So again, start by assuming the largest element is the first element of the list, so its index is 0. Right? Now in Python, because Python only has a for each loop, you have to create an object that can count 0, 1, 2, 3, 4, 5 up to and including, up to but not including the length of the list. Right? And that's what range does. Right? So range is a class. Well, so range is a class. It makes an object that can count from 0 up to but not including the length of t in increments of 1. Right? You should know that you can count in increments of something other than 1. Right? And you don't have to start at 0 or go up to this value here. Right? But you still need to make an object that the for loop can iterate over. Right? And now the rest of the code is basically the same as the previous example. Right? Now in Java, there is no object similar to range. Right? So there's no class that corresponds to a Python range in Java. Right? So in Java, you have to use an older style of loop that Java inherited from C. C probably inherited it from somewhere else. I don't know, actually know. And this was actually the only kind of loop until Java version 5, which was a long time ago now. Right? All right, so the way this works is, it comes in, I think it comes in 3 parts. Right? So it's 4, round brackets, right? And then there's something here, semicolon, something here, semicolon, something here. Okay. So the first part, this is going to be your loop variable. So in Python, in the Python example, our loop variable is I. It starts at 0, right? Goes up to but not including the length of the list. Right? So in Java, I'm going to have my loop variable I. Right? Now its type is int because this is it corresponds to an index. Right? And indexes are always integer values. Right? So I is the index. It starts at 0, semicolon. Right? Now this loop over here, it stops when I is equal to the length of the list. Right? So the other way to think about this is, in this loop here, this loop runs as long as I is less than the length of the list. Right? So the second part here is a condition that says when should the loop run. Right? So the loop should run as long as I is less than the length of the array. Right? And then the third part is what do you do at the end of the loop down here? Right? Well, I want to make I go up by 1 every time. Right? So 0, 1, 2, 3, 4, 5, 6, right? And so on and so on and so forth. Right? So that initializes the loop variable. Right? That's the condition when the loop body should run. That's what happens at the end of every loop iteration. Right? This condition here gets checked before the loop body runs. Right? So if your list is empty, then the length of the array is 0, and 0 is not less than 0, so the loop will never run. Right? If your array was empty, though, that there would cause an exception. So anyway. All right, so a regular for loop in Java has 4 main parts. Right? Part 1 is the initialization expression. Oh, I'm going to go through this one step at a time. Right? Part 2 is the termination condition. Part 3 is the update expression, and then 4 is the loop body. Right? Now, in Java and C, 1, 2, and 3 are all optional, so they don't have to be there. But it's kind of unusual to see a loop that doesn't have everything in it. Right? Every loop needs a body, so there's no way to write a loop without a loop body. And the 2 semicolons separating parts 1, 2, and 3 are always required. Right? So the initialization expression initializes the loop. It's executed exactly once when the loop begins. Right? So for int I equals 0, makes the variable called I, sets its value to 0. Right? Usually a loop variable is declared and initialized here, but not always. Right? It is possible to initialize I before the loop. Right? But often the case, it's often the case where you initialize the loop variable in the initialization expression. Part 2 is the termination expression. Right? So the termination expression if it evaluates to true, then the loop runs the next iteration. Right? So the termination condition is checked before every loop iteration. Right? As soon as that evaluates to false, the loop body does not run. Right? So this loop should run as long as our counter is less than the length of the array. Right? And then finally, the update expression is evaluated at the end of every loop iteration. Right? Almost always you modify the loop variable, but not always, right? But almost always. Right? So at the end of every loop iteration, I want to increase the value of I by 1. Right? So you can write I plus plus, you can write plus plus I, you can write I plus equals 1, you can write I equals I plus 1. They're all the same thing in this case. Right? So they'll all do the same thing, they're all perfectly valid. Most Java programmers, most Java and C programmers and C++ and C# will write I plus plus or plus plus I at the end. Okay. Now, when do you need to use this counting style loop? Right? So if you need to access more than one element of the collection every loop iteration, you probably need the counting style loop. Right? So notice that in the for each loop back here, well, the Python for each loop, right? You have to look at every element in the list, and you can only look at the current element each time. Right? If I need to compare it to the next element or the previous element or the element at the end or somewhere else, right, you can't do it using a plain old for each loop. Right? So when you need to access, when you need to access more than one element at a time, right, from a collection, you probably need the counting style loop. So if I want to check if this array is sorted, right, I need to compare every adjacent pair of elements in the array. Right? So I'm going to start by assuming that the array is sorted. Right? So I'm going to start by assuming it's sorted. It's true. Right? Now, starting at index 1, right, going up to but not including the length of the array, right, I'm going to compare the element at index I minus 1, so the previous element, to the current element. Right? This is sorted in ascending order. If this is ascending order, this is wrong. Sorted in there's a lot of typos. I apologize for this. Oh, no, sorry. Is less than, no, never mind. There's no typo here. Okay, so if the previous element of the array is bigger than the current element of the array, you're not sorted in ascending order. right? So I said is sorted to false, continue, right? And eventually, when you look at all pairs of elements in the array, you'll have the correct value of is sorted, right? If you know about the break statement in Python, there's a break statement in Java as well. You can break out of this loop at this point here, right? As soon as you know that the list is not sorted, you're done, right? So you can break out of the loop here and then just return the value of is sorted. Similarly, you could just return false here. Okay, so how does this work? So iteration 1, right? I starts as 1, right? So that's the second element in the list. I minus 1 is the previous element. There has to be a previous element because I'm starting at the second element, right? Compare the two values, 12 and 13. Is 12 bigger than 13? No, so continue, right? Is 13 bigger than 14? No, continue, and so on, right? Until you reach the end of the array, right? Now, when you hit the last element in the array, right, at the next loop iteration, the value of I will be 16. 16 is bigger than the, 16 is greater than the, 16 is not less than the length of the array, so the loop stops, right? Again, the break statement will break you out of a loop, right? So that break statement there breaks you out of this for statement here, and you end up down here, right? Just like it does in Python. Okay, so for example, when you, right, at the third iteration of the loop, right, I is 3, right? I minus 1 is 2, right? The previous element is bigger than the current element, so I know that that array is not sorted, so I can stop. Right. Here's another example where you're accessing more than one element of a list. More than one element of the array. Right. So here I'm going to reverse the elements of an array in place. Right. So I've got an array, and I want to switch their order so that the order of the array is reversed. Okay, here we go. I'm going to start out, I'm going to have 2 indexes this time, right? So to reverse an array, I need to start at the front. Let's see, you guys are, so the front of the array and the back of the array, right? So I need the index here, and I need the index here, and I want to swap those 2 elements, right? Then I want to move this index over by 1, and I want to move this index down by 1, right? And then swap those 2, right? So one way to write this loop is to create a loop where I, that's the index at the front of the array, j is the index at the back of the array. So notice that j is declared before the for loop. Right? How long should this loop run? Well, as soon as your front index passes your back index, you're done. Right? So as long as I is less than j, this loop should run. Right? At the end of every loop, I'm going to, at the end of the loop body, after every iteration, I'm going to increase the value of I by 1. And notice here, I'm going to manually decrease the value of j by 1. Right? So all you do is you just swap pairs of elements. Right? So how do you swap pairs of elements? Well, you make a temporary variable, store one of the elements, and then switch the 2 elements. Right? So temp is equal to AI, so it's equal to the element at the front. Replace the element at the front with the element at the back. Replace the element at the back with the value that's stored in temp, right? And then decrease j by 1 manually. Right, so there's your picture, right? First iteration, I is the index at the front, j is the index at the back. Switch those 2 elements, right? Move I to the right by 1, move j left by 1, right? Switch those 2 elements, right? Et cetera, et cetera, et cetera. Right, until you reach this location, this point here. Right, now you switch them. Right, you switch them, and then I goes up by 1, j goes down by 1, and now I is no longer less than j. Right, so the loop stops. Okay, now this previous example is slightly awkward the way it's written, right? Because I actually have 2 loop variables. Right, I have I and j. I declared one of them outside the loop. And then I had to manually adjust that variable inside the loop myself. Right? So in Java and C, right, C++, C#, right, you're allowed to declare more than one loop variable. Right? So I can write int I equals 0, comma, j equals length minus 1, right? And now I and j, their scope is the body of the loop, right? Similarly, for the update condition, I can update both variables, right? So I can increase I by 1, and I can decrease j by 1, right? So it's I plus plus, comma, j minus minus, right? And now you've got all of your loop variables declared declared within the for statement itself. Yes?
In theory, could you add as many variables as you want?
Yep. Becomes awkward, though, to start to initialize them all. Yeah. Yes?
What is the scope of the loop? Why did you put J outside the loop and decrease it inside the loop?
So in the previous example here, right, the scope of j is now the entire, is from here to the entire method, right? If there is more code here, right, you're allowed to use j here, right? So, which might cause problems for you, right? Here, in this case, I and j, the scope of I and j is just the body of the loop, right? Now, sometimes you actually need those loop variables after the loop is done because you need to process something that you need to use those. You might be trying to find the index of something and then you want to process that thing, right? If that's what you're doing, you have to do this. You have to declare the variable outside the loop, before the loop, if you want to use it again after the loop. Yeah?
When you declare two variables like that,
Yep.
yeah, you make them both different types?
No, that's one of the limitations. They have to both have the same type. Yeah, so that's one of the big limitations of this construct. All right, what's this one? Oh yeah, so there's actually lots of examples of when you probably want to prefer the counting style loop over a for each type of loop, right? If you can use a for each loop, it's much easier to use a for each loop, right? But sometimes you have to use a counting style loop. Another example is when you are iterating over two arrays at the same time, right? So if I have two arrays, A and B, they have the same length, or if B is longer than A, right? It's possible to add them all together. It's possible to take the sum of the two arrays, right? So sum the elements, sum the corresponding elements, and then return an array containing the summed values, right? So I've got a bunch of values in A, I've got a bunch of values in B, I want to add them all together. So A0 plus B0, A1 plus B1, and so on and so on and so forth. And I want to return those values in a new array, right? Well, you can do that, but you can't use a for each loop, because with a for each loop, I can only loop over one of the arrays, right? So if I want to compute the sum and just return that array and return the array of sums, first thing I have to do is I need to make the array of sums, right? So I make an array C, right? It's a new array that's the same length as A, right? Now that I have my array C, right, I can write my loop, right? And inside the loop, I can just write CI equals AI plus BI, right? So sum AI and BI and store it in CI and then return C. Right? So again, you need the counting style loop here as opposed to the for each loop, which only loops over one collection, right? Here I'm looping over three, right? C, A, and B. So I need the counting style loop. Okay, what about, what about the time? Okay, slicing in Python. So the Python slice is enormously useful. Unfortunately, it's also very expensive because the slice in Python actually makes a new list, right? So when you slice this list 2 through 5, that means give me elements starting at the third element, not including the sixth element. So starting at the 12, so that's index, 2, 3, 4, right? So you should get 12, 13, 14, right? What happens in Python is you get a new list. The 11, the 12, and the 13, they get copied out of the references get copied out of T and put into the new list SLC, right? So that always produces a new list in Python and does a bunch of copying, which unfortunately is expensive. Now, Java has no built-in slice operator, right? So if you want to slice an array, there's no way to do it, right? The only way to do it is to write your own method. And then there's not even a utility method in arrays to do this, right? You have to write your own method and then do it that way, right? So how do you slice an array in Java? Well, you write your own method, right? So the method's going to be called slice, right? This is going to let me slice an array of int. Right? Now, what does the slice operation need? It needs a starting index and an ending index. Right? So I need a starting index and a stopping index. Right? Both int values. Right? What does it return? It returns a new array containing the elements at ARR start up to but not including ARR stop. Right? So it's going to return an array of int. Right? Now, whenever you can, you should validate the inputs to your method. Right? So if you're writing this method for people to use, yourself, your friend, lots of other people perhaps, right? You want to make the method to be as safe as use as possible. Right? So in other words, you want to check for errors that might happen. Right? So for the slice operation, there's a bunch of errors that might happen. Right? And they're all related to, they're all related to that start and stop index. Right? So if you use an invalid start index or an invalid stop index, right, those are going to cause problems. Right? You really should check for those. Right? One of the conditions that I'm going to check for is the start index greater than the stop index? Right? Because if it is, that doesn't make sense. Right? So I want to check for that condition, and then I want to indicate that this is a mistake. Right? And so the way that you indicate that this is a mistake is you throw an exception. Right? In Python, if they told you how to do this, you would raise an exception. Right? In Java, you throw an exception. Right? So here, I'm going to throw. Right? So that's the keyword throw. Right? You need the name of some kind of exception type. Right? And so one of the most common exception types in Java is illegal argument exception, right? Indicating that there's something wrong with one of your inputs. Right? And you need the keyword new. Right? So throw new illegal argument exception, round bracket, some string that's a message. Right? So here I'm just going to print the message start is greater than stop. Sorry, I'm going to include the message start is greater than stop. Right? And that's a problem. You could check for lots of other issues too. Right? You can check if start is less, well, you should check for these. You can check if start is less than 0. You can check if stop is less than 0. You should check if start is greater than ARR.length minus 1. And you should check if stop is greater than ARR.length. Right? Okay, so assuming you make those checks here, they're not all on the slide because there's a lot of them. Right? How does the rest of this work? Well, I need to make the array that contains the slice. Right? So there's my array that contains the slice. Right? How long is the array? Well, let's go back here. Right? So if I do 5 minus 2, that gives me 3. Right? And there are, in fact, 3 elements in the slice. So how many elements are in the slice? Well, it's stop minus start in this case. Right? Once you have your array, what do you want to do? You want to copy the elements out of the original array into slice, into SLC. Right? So how do you do this? Right? So what you have to remember here is that you're starting at that index in that array, right? And you're stopping before that index in the original array. Right? So I is going to be my index into the array ARR. Right? I'm going to start at start. I'm going to stop before I gets to stop. Right? Each time through the array, through the loop, I'm going to increase the counter by 1. Right? And now the only slightly tricky part of this method here is the index for slice. Right? So when you start at index start of ARR, that has to go into element 0 of SLC. Right? Start plus 1 goes into element 1 of SLC. Right? Start plus 2 goes into element 2 of SLC. Right? So you have to subtract start from the value I to get the correct index in slice. Once you're done that, I've copied all the elements from the original array into the slice. I can return the slice. All right. How do you use slice? Okay, so assuming we're in the lecture 4 class, and I've got my method slice in lecture 4, right? I can write a little main method. I can make a little array t, right? Set some values, right? And now I can call slice, right? So it's just lecture 4 dot slice, name of the array 2 and 5, right? The starting and stopping indexes of the array. Right? So that's how you'd call slice there. All right. So there was an update to OnQ. There are now some links to videos that show you how to use Eclipse. The videos are, what are they? So they show you how to start Eclipse, create a project, create a package, navigate yourself around the Eclipse interface, and it tells you what file structure Eclipse generates. These are all important things. So you should watch that video if you don't know how to use Eclipse, right? And then you should take a look at assignment 1. Right? Any questions? Super. I'll see you on Wednesday.